So the people from the Hunger Games came to me and they asked me if I wanted to do an experiment that would be related to power generation. And strangely, there is this one idea that I've been thinking about for years, and now finally I have the chance to do it. Come check it out.
First positions, here we go. Set, and dolly, lights, and action.
We have a setup here with two rain shower heads making two streams of water. Now, each stream is going to pass through a set of coils right up by where they're released, and then it passes through this wire mesh down below. Now, these two sets of coils, so this set of coils is separate from this set of coils, and they're each connected to one of these balls here. Once we get the water flowing, we should be able to generate a little electric spark right here. There it is. What's incredible is that we're generating a spark which is probably 5,000 to 10,000 volts. It would give you a decent little shock. I mean, it's not actually dangerous because although the voltage is high, there's not that much charge behind it, so you can't get that much current flowing, and current is what really does damage. Now the question is, how, just out of this setup where we have falling water and some pieces of metal, do we generate 10,000 volts? Well, the way it works is that normally water is perfectly neutral. There's even numbers of positive ions and negative ions, but as the water comes out of these two shower heads, sometimes there's going to be a slight imbalance, maybe a little bit more negative in this stream and a little bit more positive in that stream. Now normally that just kind of washes out over time.
But not in this case. Here's the ingenious part. The mesh on the left is connected to the ring on the right. So if this mesh becomes negatively charged, then so does this ring. And now that ring will attract the positively charged water.
So this whole stream becomes positively charged. Therefore, when it lands on this mesh becomes positively charged as well, which means this coil over here is positively charged, forcing the negative ions to be coming out of this stream more.
And so what we have is a clear separation of charge. There's a positively charged stream on the right and a negatively charged stream on the left.
If you look closely at the streams, what you can actually see is they get more and more attracted to these top coils, and then the spark goes and they reset. So basically what's happening is we're building up charge on these coils, and then when the charge gets big enough, it jumps across from the negative side to the positive side, and everything becomes neutral again, and the charging process can start afresh. It's a pretty phenomenal piece of physics. I mean, it's such a basic setup, and yet it produces this very impressive result. This was noticed over 100 years ago by a guy named Lord Kelvin, so it's often called Lord Kelvin's water dropper or Lord Kelvin's rainstorm. It's a really impressive phenomenon. But you might be wondering, how much energy could I really get out of this system? Well, to put this in perspective, if you were to charge your phone on the energy generated by this setup, it would take 6.5 years to reach full charge. So this is a very tiny amount of energy generation that we're talking about. You know, an interesting thing to consider is, where does this electrical energy come from? All we really have is just falling water and metal pipes. I want you to leave me your answer in the comments below, or make me a video response.